3 slides, and then I have to do some stuff on the board. Okay. So maybe this isn't going to work. There we go. Okay. So first of all, the way I'm going to break these 2 chapters down is we're going to tackle ionic bonding and ionic compounds and naming writing formulas for ionic stuff. And then we're going to move to covalent, and then we'll talk about metallic, and then we'll talk about hydrogen bonding. So we'll kind of chunk the chapter up. So to start with, and tomorrow we're really going to be dealing with binary compounds and ternary compounds. That's how you pronounce that. Binary, bi means 2. Binary compounds are compounds with 2 elements in them. Okay. Ionic, so you're going to have 1 cation, you're going to have 1 anion. Cation is always going to be in the front of the compound, like I said before. Anion is always going to be in the back. Ternary ionic compounds are compounds that have 3 or more different elements in the compound. Okay. A ternary ionic compound is still going to have ions. It's still going to have a cation. It's still going to have an anion. However, you might have a polyatomic ion present, which would give you several elements in the compound, 3 or more. So if there is 3 or more elements in the chemical formula, I guarantee you there's a polyatomic ion in there somewhere. Okay? The only 2 types of compounds we're going to be dealing with ionically are binary and ternary. And I was going to say, we covered some of this in physical science, but this was all COVID stuff. So those of you I had as freshmen for physical science, we didn't even get to this chapter, so this might be a little bit new to everybody. Okay, so tomorrow we are going to tackle binary, ternary ionic compounds. We're going to name them and we're going to write formulas, okay? I just want to, while we're talking about compounds and molecules, I do want to define, and there's several ways you can say this, okay? Molecules have several names. We can just call them a molecule. We could call them a covalent molecule. You might hear it called a molecular compound. You might call it a covalent compound. These are all names for molecules. So if I said covalent compound, I'm still talking about a molecule. If I'm talking about a molecular compound, I'm talking about a molecule. Okay? Just goes by many different names. Covalent molecules or molecules or molecular compounds, these are substances that share valence electrons, okay, that have covalent bonds in them. Some combinations you're going to see all nonmetals. Like we had a few examples in Bell work yesterday. You might see a metalloid and a nonmetal. So tomorrow we're going to tackle ionic compounds. The next week we're going to look at covalent molecules and covalent compounds. Now, when we're dealing with both types of compounds, we are very much, and you guys have already been exposed to it, but we're very much going to be dealing with chemical formulas. And this is information that we talked about briefly, I think, chapter 1. But we're actually going to be dealing with chemical formulas starting tomorrow. Okay? Chemical formulas, of course, represent substances, represents the names of substances. So instead of having to write sodium chloride, we write NaCl. Instead of writing magnesium sulfate, I would write MgSO4. So chemical formulas are going to represent the name of chemical compounds, molecular and ionic. Several things you're going to see in your chemical formulas, and again, this is a reminder. I know we covered this chapter 1. Chemical formulas are going to have elemental symbols, more than one for sure. You're either going to have 2 elemental symbols or more than 2. You're going to have subscripts. Those are the numbers that are written below, and that tells us how many atoms are present in each compound or in each molecule. You're also going to see superscripts. Those are the numbers that are written above, and those are going to represent the ion charges. And you guys have already been exposed to that. Like all of the elements in group 1 form a +1 ion, so 1 plus, or when we wrote the ion symbols like Ba 2 plus. So you've already been exposed to those superscripts. Good. Okay, so before we can start writing chemical formulas and naming compounds, okay, we have to talk about oxidation numbers. So make sure your periodic table is handy, okay? So let me give you some definitions and then we'll look at that periodic table. So this is a really technical definition, but oxidation numbers, okay, these are numbers, these are the superscripts that we're going to be using, okay? Oxidation numbers are numbers that describe the real or apparent charge for an atom or ion. Oh, I don't know what I was trying to say there. Let me try and fix that. There we go. There we go. Numbers that describe the real or apparent charge for an atom or ion. An oxidation number is literally the charge on an ion. And let me explain what that means apparent. Okay? So numbers that describe the real or apparent charge for an atom or an ion. Ions have real charges to them. They form ions. They have true charges. We call those charges oxidation. Okay? However, sometimes atoms are going to be found in molecules and the electrons are going to be shared. So they don't form true ions. But we could assign these oxidation numbers to the atoms in a molecule to show that the molecule is balanced out. That's where the term apparent comes from. We're not going to do that. We are solely going to be just dealing with the true ions charge. And that is just, we call it an oxidation number. Okay? So when all of the elements in group 1 form a +1 ion, this is sodium's oxidation number. All the elements in group 1 have a +1 oxidation number because it has a +1 charge, right? Didn't we write these above your periodic table? Yeah. Okay. And then elements in group 2, like barium, barium has a +2 oxidation number or a +2 charge. So the charges that we wrote above those groups, those charges are, okay, their oxidation numbers. So you guys already know a handful of oxidation numbers because we were already dealing with the charges before. Does that make sense? Charge is equal to oxidation number. So Cl -1, the -1 charge is chlorine's oxidation. Okay? Okay, so a few things. Get that polyatomic ion list out as well. We're going to need that. So the sum of an atom's oxidation numbers in a formula are always going to equal 0. Okay? We literally just use our oxidation numbers to make sure our chemical formulas are correct. So if I use my example over here, Na2S sodium sulfide, so the sum of all of the oxidation numbers in a compound or molecule is always going to equal 0. Okay? So sodium sulfide, sodium has a +1 oxidation number, and I've got 2 of them. So 2 times +1 gives me +2. What's sulfur's oxidation number? Look on your periodic table real quick. Look above group 16. What is it? It's -2. So we use these oxidation numbers to help make sure our formula is correct. So when we add all of the oxidation numbers up for all of the elements or all of the atoms in a formula, it's going to sum up to be 0. Because all compounds and all molecules are neutral. They don't have a charge to them. So those charges are going to equal 0. The oxidation number for polyatomic ions are the charge on the ion. So that list of polyatomic ions that I gave you, that has the charge, like sulfate is -2, carbonate is -2, hydroxide is -1. So the charge on the polyatomic ion is the oxidation. For monoatomic ions, like the ones I had up here, like potassium +1, barium +2, bromine -1. For monoatomic ions, the oxidation number is the charge. It's just a term we use when we write formulas. We don't usually say, sum up the charges. We say sum up the oxidation numbers, or assign the oxidation numbers to the atoms in the formula. Oxidation number is the charge. It's just a fancy way of saying charge. Okay? Now, a few exceptions to these rules right here. Just a few, not a lot. So some exceptions to our oxidation rules. If hydrogen is in the back of a compound, okay, if it is bonded to a metal and it's in the back of the compound, hydrogen's oxidation number is -1. Because normally it's +1, right? It's found in group 1, so it'd be +1. So normally hydrogen is +1. But if it is found in the back of a compound, as in the if it's bonded to a metal and hydrogen is in the back, it's acting like an anion in that case. And it would be -1, it wouldn't be +1. So that's one exception. Well, hello, Bennett.
Hello.
Oh, checked skyward, did you?
Yep.
Okay. Our second exception is some metal, and it's only metals. It has nothing to do with non-metals. Some metals have more than one oxidation number. I'll let you write this down and we'll go to the periodic table. So like for instance, all the metals in group 1 and hydrogen, they're always +1, okay? All of the elements, all of the metals in group 2, they're always +2. Okay? However, there's a handful of metals on the periodic table that don't have just a single oxidation number. Sometimes they have more than one. So grab your periodic table once you're done writing. And let's start with lead and tin. Okay? Lead and tin are found in group 14, so you would normally think that its oxidation number might be +4 or -4, and sometimes it is. But if you look at tin, Sn, there's two small numbers right above it. Okay? Those are the charges or the oxidation numbers that tin could have. Tin could have a +4 oxidation number, or it could have a +2, meaning tin could give away 4 electrons when it bonds, or it could give away 2. You won't know what it's doing till you see it in the compound. Okay? You won't know if it's giving away 4, you won't know if it's giving away 2 until you see the actual compound. Lead is the same. Lead is right underneath tin. Okay? So its oxidation numbers, or sometimes they call them oxidation states. Okay? Lead could be 2 or it could be 4, meaning lead could give away 2 and become a +2 cation, or it could give away 4 and become +4. It just all depends on what compound it actually forms. Now, some other metals that do that are the metals, the transition metals. So the metals from group 3 to group 12, if we take a look at several of them, like iron, iron could have an oxidation number of 3, of 2, or of 6, meaning iron could give away 2 electrons, it could give away 3, or it could give away 6, okay, depending on what compound it's forming. So when you look at these, and it's only the metals, it has nothing to do with non-metals, okay, only the transition metals and tin and lead, okay, all the others, you're going to follow those numbers that we wrote above the periodic table. Now, if you look at silver, silver's atomic number 47. If you look right above the symbol, its oxidation number is 1. And it's only 1. Okay, if there's only one number present above the symbol, and again, I'm only talking about the transition metals, tin and lead. There's only one number present, that means it only has one oxidation number. It's only ever going to do one thing. Same with indium, let's go with cadmium. Cadmium is going to be +2. Zinc is always +2. Many of them have more than one oxidation number, but a few of them only have one. Yes?
What would noble gases be?
Noble gases are going to be oxidation number of 0.
Okay.
And that's because they're back to the one bond. That's a really good question. Okay? Yeah, oxidation number of 0. Okay. Are we okay? We have to talk about polyatomic ions now. So we're done with oxidation numbers. And all of this is going to help us with tomorrow's stuff. So now I want to look at polyatomic ions. So get that list out. we're going to use it. And if you have a highlight, if you like to highlight stuff, you're going to need a highlighter. If you want to borrow a highlighter, yes. Look in that folder. Look in either one of them. It'll say master list of polyatomic ions. Yeah, just come grab one off my desk.
Color do you want?
Yeah. I've got it going if you want. Well, hopefully mine works. Yeah. We're going to do some stuff on the board. Okay, so first of all, these polyatomic ions I have listed, find them on your list and highlight them. Okay, there's I think 12 of them. Notice they all end in ATE. So you're looking for bromate, chlorate, iodate, nitrate, borate, carbonate, chromate, oxalate, sulfate, arsenate, and silicate.
I think I got one. Like actually.
Huh?
Phosphate?
Yeah, phosphate and silicate. Did I not say phosphate?
No.
Oh, I'm sorry. So when you look at all of these, what do they all have in common? Look at the formulas. What do they all have in common? Okay, so they all end in 8. That's common in their name. What about their formulas? What's common for all of them? They're all, did I hear negative? Correct. And then they all have what? They all have oxygen. Very good. Okay. So these guys, so with your highlighter, like on the top, make yourself a little key that says main version. These are the main versions of what we call Oxy Anions. What do you think oxy refers to? Good. And what does anion mean? Negative. So these are all, okay, now there's more. These are the only ones we're going to focus on though, okay? These are all called Oxy Anions. They all are negatively charged, like you guys said. They all have oxygen, okay? These, yes. I would put that in your notes, okay? Super good question. Now, oxyanions come in families, okay? You don't have the rest of the family members on your list. You're going to be able to come up with them with the few rules that I'm going to give you, okay? So when it comes to oxyanions, and I'll put this up so you can write it, oxyanions come in families. You have the main version or the head of the family on your list. You don't have the siblings or the kids on your list. I'm going to give you some rules, and we're going to be able to come up with the rest of the family members. So for instance, oxyanions form families of anions. These family members are related in that they have the same elements, okay, and they have the same charge, but they're different because they have a different number of oxygen atoms. So when we're talking about oxyanions, the family members will always have the same charge. They're always going to have the same elements, but their oxygen number is going to be different. God, we are behind. So this is an example of a family of oxyanions. The only one you have on your list from down here is CO3 minus 2. That's carbonate. You don't have the rest of the family members on your list. But we're going to be able to name these and come up with these with just a few rules. This is where I'm going to come to the board. Now again, the list that you have in front of you, I will give you that exact same list for tests and quizzes, okay? You don't have to memorize anything on there, okay? I'll give you that exact same list. So we're going to name, okay, the rest of the family members. That's what we're going to do. I'm going to give you some rules to name the rest of the family members. And this, we only do this with those ones that we highlighted. All the rest of them don't have family members. I'm going to go too fast. You good? Aren't you guys? Was that okay? Did you finish? Okay. Okay. So we're going to start over here. Main version is on your list, and it's going to end in ATE, right? All of those, phosphate, sulfate, oxalate, they all end in ATE. So an example, we'll use sulfate, SO4 2-. That's your main version. He's on your list. He ends in ATE. So one of his family members is SO3 minus 2. Okay? So how is he different than the original version? 3 oxygen instead of 4. So here's our first rule. 1 less oxygen drop 8 and make the ending ITE. So if you look at the formula and you're like, oh, that's 1 less than sulfate. To name it, I'm going to drop the 8 and I'm going to add ITE. Now we know this guy is sulfate because it's on your list. So if he's 1 less oxygen, what am I going to name this guy? Drop the 8. Sulfite. This guy is sulfite. He's the first family member that's not on your list. SO2 minus 2. So how is he different than our main version? 2 less. Okay. So if I have, I'm going to come over here. 2 less oxygen. You're going to add hypo as your prefix. And then you're going to drop 8, make it ITE. So if I had 2 less oxygens in my formula from the original version, I'm going to add the prefix hypo, drop the 8, and make it ite to come up with the name of my next family member. So how am I going to name SO2 minus 2? Perfect. Hypo, sulfite. Excellent, excellent, excellent. So 1 less gets ite, 2 less gets hypoite. Okay, we only have 1 more. Okay, so 1 more oxygen add prefix per, and that's it. So if my formula is SO52 minus, how am I going to name him? Perfect. Persulfate. Perfect. So let's say I have a polyatomic ion that looks like this. ClO4 minus. Let's say we want to name this guy. So the first thing you're going to do is you're going to scan your highlighted and you're going to see what polyatomic ion looks extremely similar to this. Chlorate, right? So how are my oxygen different? 1. It's 1 more, right? So how am I going to name this guy? Perchlorate. So my suggestion is this. You look on your list and you scan it. And if you don't have the exact polyatomic ion in there, it's going to be some version. Okay? So if I was to say, let's do CO2 minus. So scan your highlighted list, and what polyatomic ion looks darn similar to that? Carbonate. Okay, so our original is CO3 2 minus. So how's my oxygen different? 2 less, right? So 2 less, we get what on the front? Hypo. B-O-N, and then how do I end it? Hypocarbonite. So you always look on your list, and if you don't have the actual one, you're going to have to move to these rules, okay, to come up with this. Now let's do it let's do the flip side. Let's come up with the formulas from the names real quick here. We'll just do a few. And you probably will not have an assignment. Okay, so let's go in the opposite direction. Oh, do you guys have WSU meeting? No. What? Oh, okay. What time does the bell ring? 06? Yeah, I'll probably not give an assignment.
Yeah, it's 14.
Oh, is it 14? No.
No, but you don't have to give them.
No,
No,
it's
we
six.
have to. It's a.
Is
Don't
it
do
a
it.
6 or 6?
It's
Yeah, it's a 6. It's a 6.
Okay, how about I do this? And I got one thing left to do. Sorry, ladies.
Yeah. Stop.
Text somebody. I'll make my decision in a second. It's Friday Eve.
Come on.
Okay, so hold on, and I do realize you guys have been writing notes. Text somebody, let them know. I'll let you know in a few minutes. So phosphite. So scan your list, and what polyatomic ion is very similar to phosphite? Phosphate. So phosphate is PO4 3-, right? So it ends in ITE, so what does that change for our oxygen? One less. So my actual formula for phosphite would be -3. Sorry. Per iodate. So look on your list and see what is very similar to per iodate. Iodate, which is IO3 -1, is that correct? Okay. Per means what? One more, so my formula would be IO4 1-. Hypochlorite, so scan the list. Okay, 2 less, so the original is ClO3, right, 1-. And Issa said 2 less, so my formula would be what? Very good. You guys are awesome. Oh, I won't give you assignment. No assignment. We'll pick up tomorrow.
Everybody
I'll
tells
just-
Hayden he tells you that this time.
No, don't tell them that. They'll freak out. No, that was a lot of notes for you guys to have to take.